Hello guys, welcome to my channel. This is Saddam and today we are going to do vectors and kinematics as I have started this Kleppner and Kolenkow book. My previous videos was about what is this Kleppner and Kolenkow, what is the preface, why we are actually using this book, and what were the contents. And we have talked about many things while introducing this book with you. So today, be specific, I will do something, I will write something, and let's start today with vectors and kinematics. We will see closely, first of all, what is vectors. I know you know it, but basically just frame by frame, time by time, as you can understand, my videos has no time limits. It cost me the subscriber, but my main goal is to give you a great understanding. Mechanics is at heart of physics. Its concepts are essential for understanding the world around us and phenomena on scales from atomic to cosmic. Wow, do you understand it? Physics is the heart of mechanics is the heart of physics, as I have already told you. Its concepts are essential for understanding the world around us and phenomena on scales from atomic to cosmic. जैसे कि if you want to understand the cosmology or galaxies, anything like rotations, why we are getting some light, how can we understand how far galaxy is, every understanding of anything from atom to cosmos, the main starting point is our mechanics. So everything, every concept is actually given by mechanics. That's why we say that the core of physics is again mechanics. Concepts such as momentum, now here it is, concepts such as momentum, angular momentum, and energy play roles in practically every area of physics. The goal of this book is to help you acquire a deep understanding of the principle of mechanics. Get it, my point? The reason we start by discussing vectors and kinematics rather than plunging into dynamics is that we want to use this tool freely in discussing physical principle. कहने का मतलब ये है कि हम तो सीधे सीधे स्टार्ट कर सकते थे डायनेमिक्स से कि चलो भाई बात करते हैं पृथ्वी या planet, how the planet is actually going around the sun, why things are happening, what is the phenomena of creating clouds, and how this chaotic thing happens in the world. But before doing that, we want to little bit and have some understanding or revision of vector and kinematics, because there are so many things which you are not familiar of, like coordinates, what actually vector is. Like we used to draw some kind of arrow, and we do have some algebraic thing, like we can add two vectors, we can multiply two vectors, we can have some subtraction. But what is the role of vector in a bigger frame, and how, if we want to play with general relativity, as Einstein had said that Newtonian physics is not a only physics. The idea of Newton's gravity is limited. You have to move something, we have to move towards something different. We are calling that tensor calculus. To understand that part, you have to understand something more about vectors. So whatever we have understood so far, like the S.C. Burma or any 12 standard book we have introduced so far, like this one, like some quantity is a vector quantity and some quantity is a scalar quantity. We can add two vectors, we have some directions, we have so and so and so. But the thing is, the main question is, what is this goddamn vector? So we will now study. That is the reason to introduce this part. That's why he has said, rather than interrupt the flow of discussion later, we are taking some time to ensure they are on hand when required. So that's why we are going to revise it. You have to have a better understanding of the previous thing that you have already finished. And later on you cannot say, sir आपने तो ये नहीं पढ़ाया, मेरे को तो ये पता नहीं चल रहा है, वो blah. बेटा, ये आपका क्लास ऑफलाइन नहीं है. You cannot now tell me that, you cannot blame me now that I haven't covered it. चलो आपका टाइम मैं बहुत बर्बाद किया. Let's get back to another section, that is 1.2, what is vector. The topic of vectors provide a natural introduction to the role of mathematics in physics. Hang on a second. The topic of vectors provide a natural introduction to the role of mathematics in physics. Yeah, very good. क्योंकि हम पहले से ही जानते हैं, इवन इफ 9th स्टैंडर्ड से ही यार, कि वेक्टर आ गया और हम फोर्स को वेक्टर्स में लिखते हैं, डिस्प्लेसमेंट को वेक्टर्स में लिखते हैं, मीन्स के वेक्टर का और मैथमेटिक्स का एक गहरा संबंध है. By using vector notation, physical laws can often be written in compact and simple form. Great. Modern vector notation was invented by physicist Willard Gibbs of Yale University. So if you want to become an IAS, maybe it will be the question that who has invented this kind of, silly notations of vectors. He is Willard Gibbs of Yale University. My God, amazing. Primarily to simplify the appearance of equations. For example, here is how Newton's second law appears in 19th century notation. 19th सेंचुरी में मीन्स कि जब हम लोग 1800 के आसपास थे, तब उस जमाने के फिजिस्ट कैसे लिखा करते थे. चलो भाई, फोर्स एक 3 डायमेंशनल ऑब्जेक्ट है, तो x के डायरेक्शन में m_ax होगा, y के डायरेक्शन में m_y_ay होगा, f_z_m_az होगा. तो लोग पहले ऐसे लिखते थे. बट जैसे जैसे 19th सेंचुरी ख़त्म हुआ तो लोगों ने अब शुरू क्या किया कि वी हैव टू स्टडी इन वेरी कॉम्पैक्ट नोटेशन. यानी कि जब आइंस्टाइन का ज़माना शुरू हुआ तब लोगों ने कहा कि चलो भाई छोड़ दो, और लोगों ने सबसे पहले ये इंट्रोड्यूस किया एक इंटरेस्टिंग थिंग, लाइक अगर मैंने कोई लिखा है वेक्टर है तो बस मैं उसे एरो लगा दूंगा. या लोगों ने बोल्ड लेटर में लिखना शुरू किया, जैसे कि उसमें रिप्रेजेंट किया हुआ था. बोल्ड में ए होगा तो वेक्टर होगा, या ए के ऊपर एरो होगा. बट यार इतनी लंबी बुक लिखनी है, कौन बार बार एरो लगाए, इसीलिए लोगों ने बोल्ड लेटर में लिखना शुरू किया अगर कोई भी क्वांटिटी वेक्टर है तो ए वेक्टर को हम इस तरह से डिनोट करेंगे. सो दैट्स वाई now people have introduced a very compact notation to simplify or appearing that okay, which is vector, which is scalar. Amazing. Our principal motivation to introduce vector is to simplify the form of equations. Obviously everybody likes simplification, and also my users, my subscribers also demand that please make your video as simple as possible. I am sorry, please subscribe me. Please subscribe, not me, my channel. Okay, pardon. However, we shall see in chapter 14, vectors have much deeper significance. ओ भाई, तुम्हें 13 चैप्टर तक वेट करना पड़ेगा इसके अगर डीपर सिग्निफिकेंस को देखना है तो. आई एम सॉरी फॉर दैट. Vectors are closely related to the fundamental ideas of symmetry, and their use can lead to valuable insight into possible form of unknown laws. क्या बोल दिया भाई तुमने? मीन्स कि अगर हम कोई एक वेक्टर को लिखते हैं तो ही सेज दैट इट हैज सम काइंड ऑफ अ सिमेट्री. सिमेट्री मीन्स व्हाट? सिमेट्री मीन्स सपोज you are here and there is in front of your mirror, so you see here is a symmetry, means your other half is same as your next half. You got symmetry. So this means that this A vector does have kind of a symmetry, and this kind of symmetry can lead us to more insight in physics. What is this? Are you playing with us some kind of stupid game? That symmetry can actually lead us to something deeper? What can be more deeper than F is equal to ma and solving some dynamical equation? I don't understand it. How one can actually using some simplistic form like symmetry or like mirror symmetry idea to actually figure out something deeper in physics. No. I reject this idea. It cannot be done. Okay, definition of vectors. Mathematicians think of a vector as set of numbers accompanied by rules for how they change when coordinate system is changed. भगवान हमारा भला करे. अच्छा है कि हम लोग मैथमेटिशियन ना हैं, वरना क्या होता. ये कहते हैं कि सेट ऑफ नंबर्स चेंज बाय अकॉर्डिंग टू सम रूल, और वो रूल कहाँ से कंप्लाई कर रहा है? कोऑर्डिनेट सिस्टम के साथ. भाई ये तो क्या कह रहा है? मेरे को तो वेक्टर को आता है. वेक्टर बोले तो ए वेक्टर इज इक्वल टू, अगर तुमने कोई वेक्टर जोड़ दिया तो ऐसा होता है वेक्टर. और हमने पहले देख रखा है कि वेक्टर को हम नोटेट कर रहे हैं एक किसी ना किसी एरो से. Now you are telling me that you got to understand some coordinate, and vectors are some mathematical numbers like 1, 2 and 3 and so on, and it has certain rule of changing, and from that changing you are actually describing your vectors. My god, and this is real physics. Actually what happens is that, as you understand from the earlier definition, that vectors and mathematics is completely linked together. So mathematicians used to study this in terms of very very interesting manner, like how they if I am changing some coordinate system, then in coordinate system we are actually defining everything, like vectors also we are defining on some coordinate system. So if the coordinate system is changing by certain rules, then the vector has to follow that kind of rule. If any quantity is not changing with that rule, it means that it is not vector. So that has a deeper meaning. But now you cannot see you cannot see that deeper role here, how it will come into play, how it will come in our understanding, we will see in a minute. But later on we will see it. For our purpose, a down to earth geometric definition we will do. Okay, no problem. Now to describe a vector we must specify both its length and its direction. Okay, ये तो मुझे पता था. Unless indicated otherwise, we shall assume that parallel translation does not change a vector. Thus the arrow in sketch all represents the same. Means what? Now we will stick to it. What does it imply? Imply means that, let's leave the coordinate part and let us see something simple. Simple means that a vector is represented by arrow, and if you have not specified anything, for example there are several vectors, and if they are in the same orientation they will be simply added. Okay, so we are saying that they are already parallel to each other, so these vectors have the same property. Secondly, these vectors have a magnitude, means a number, and it has this unit vectors. So a unit vector has definition that it has the length 1, okay, and it is dimensionless. It doesn't have any dimension, and basically a vector is represented by a magnitude that I have already told you. This is the magnitude of the vector and this unit vector, and unit vector is represented by a hat. We are calling it a hat, and in book they have written like a caret. So the vector of unit length parallel to a is a hat. Okay, this is we call caret, but I am going to use it a hat, not caret. Okay, caret means गाजर. भाई मेरे को गाजर नहीं खाना है, ठीक है, अभी तो मेरे को गाजर नहीं खाना है, तो हम यूज करेंगे a hat. So that is the funda of the vectors, like a vector that has magnitude and its unit vector, and unit vector no dimension it has, and the direction of unit vector is parallel to this big vector. So maybe this is your unit vector. So we always say that this unit vector is representing the increasing direction of any vector. Means that if your vector is going this side, means the unit vector is representing this side also. If your vector is in this way, your unit vector is also in this side. So this is the rule. Okay, next thing, if it is clear to you, the algebra of vectors, we will need to add, hang on a second, one thing very interesting that I am going to tell you. We will need to add, subtract and multiply two vectors and carry out some related operations. We will not attempt to divide two vectors since the need never arises, but to compensate for this omission we will define two types of vector multiplication, both of which turn out to be quite useful. Here is a summary of basic algebra of vectors. Now you may ask that, okay, this is a physics class and this is an advanced physics class. We are learning some advanced mathematics, advanced physics, advanced part of mechanics. As you have already defined now that to understand vector, we need to have some coordinate. Now before you are using any kind of coordinate, like we have Euler coordinate, you are actually moving towards subtraction, means algebra of vectors. I didn't get it. My dear friend, that is the interesting thing about vector. You know, to understand vector mainly, or in order to do some operation of vector, you don't need to define any coordinates. Means that a vector can be defined, or some operations of vector can be defined independent of coordinate system. No matter whatever the coordinate system is, these vectors will follow these kind of rules. So if you are now, so this statement is very crucial, because when you learn some high energy physics like condensed matter physics, maybe some group theory, where they are extensively using this kind of thing, so they again you will define what is vectors, okay, in some arbitrary space. But you know, the operation of vector, no matter in which kind of space you are, space means the coordinate system. Maybe your coordinate system is just like simple XYZ. Some coordinate system are like spherical one, some coordinate system are like curvy one. So no matter what kind of space you got, the operations of vector never changes. Means that if you got two vectors like here, it will produce another vector. Now if you change the direction or order of two vectors, the resultant vector will same. If you subtract two vector, it depends on the magnitude of one vector to another, and it will produce something like C vector. The sign may depend on the which vector is greater. Now you can add two vectors when they are parallel. So if two vectors can be added if they are parallel, or if they are anti-parallel. So one vector is this side, one vector is this side, then they can be added or subtracted. So these guys are actually subtracting, okay. But you cannot add these two vectors, like one vector is this way, another vector is this way. This cannot be added here, okay. Similarly, to add these vectors, you have to first make that happen, that what is the component of this vector in this side, and you have to make one unit vector in this side, that what is the unit vector in this side, then you can generally add. So to add any arbitrary vector, you have to first make sure that these two vectors are aligned each other. So if they are this way, they can be added. If they are this way, then they can be added. So if they are in general, you have to divide it in terms of components. What is the component in this direction, and then you can add or subtract it. So I think you understand a little bit of vector addition. Now it follows the commutative rule. Just I have already defined that a plus b is similar to b plus a. If you multiply any vector by some kind of constant, it will not change its direction unless a is not negative. So if a is not negative, if this not happens, this just simply magnifies. So for example, your a vector was this much, after multiplication of certain number, it will simply amplify a times, okay. So this actually happens. But when it comes to multiplication of two vectors, multiplications like I have two vectors a cross b, you want to multiply. Now multiplication can be two type, a cross b or a dot b. So we are calling this vector multiplication, and this we call it scalar multiplication. This happens like if you got a vector and you got b vector, and they are actually apart by some kind of angles, what we can say that the resultant angle will be like a cross b. So the resultant vector will be nothing but a b sine theta, and these are magnitudes of a b sine theta, okay. So they are actually following something we call right hand rule. To find the orientation, to find the what is the resultant. So A cross B means that if you got A and you got some vector B in this direction, so A cross B means that A is actually going towards B. So if you have some kind of a screw here, you just simply rotate this way, means that you got something like, let me just make another figure here. For an example, here is a A, here is a B, and you got something to screw it, so it is fitted with this one. So if you rotate this guy here, so it will simply go back to this side. So this is the meaning of it. So if maybe it is in X direction, it is in Y direction, and it is in Z direction, so C will be in Z direction, because you are actually rotating this way, and we are considering that anti-clockwise in this direction, clockwise will go downwards. So C is equal to A cross B. So that is the meaning of this thing. It says this how you gonna tighten your screw. Means that if you have some kind of a bottle, okay, and you have some kind of cork here, you know, the close. So how you gonna rotate? You will rotate this way, then it will go upside. If you rotate this side, it will go downstairs. So it has, so the vector, so vector multiplication or cross product is linked with rotation of vector. I hope you understood this part. Secondly, another part is called scalar product. So how we actually understand scalar product? So if I dotted two product, it will give you only C. C is your number. There is no any direction. So C is your A, B and cos theta. Okay, so if you have two vectors like A and B, and you have some angle they are inclined towards, therefore C will give you again cos theta. So it will depend on theta. So if your theta is 0, means both are parallel, like A and B are in the same direction, so C will be AB. This is the maximum. So both in the vector condition like A cross B, it depends on sin theta. A dot B, it depends on cos theta. Got it? So they are the function of some trigonometric function, and I hope you understand about sin theta and cos theta, when they are maximum, when they are minimum, and when they are 0. Okay, so that is the pretty much understanding of algebra. Now one more interesting thing about vector multiplication and scalar multiplication is, like if you change its order, like A cross B is never equal to B cross A. You can understand just by rotating. Just you have the bottle and you tighten the screw, so you have to operate this way to tighten the screw, and if you want to open this button, you have to rotate this by side. So this rotation and this rotation are not exactly same. This rotation goes this way effect, and this rotation have effect upper side, and both vectors are anti. Okay, so they are opposite with each other, therefore they are not the same. While you are in scalar product, these actually produces only number, so A dot B is equal to B dot A, therefore we say it is commutative, while this is not commutative. So this is the very interesting thing about this vector, that a vector product is never to be commutative, while this scalar product is commutative. So if I am multiplying some number over this guy, okay, this will simply change the length like A cross B, and simply if I am multiplying with this thing, it will simply like AC, it will give you another number. So there is no much changes here like in the vector direction, just the amplification of one vector or another vector, the resultant vector will be amplified. So this is the more or less the way we actually do this kind of vector. Now if you want to find the resultant vector, okay, the resultant vector, so I am doing it fast because I am assuming that you have some understanding of vectors, and I am doing it because for the sake of some revisions. Like we have these two. Let me go another section. Okay, so sorry for the delay. Now if you have two vectors like a and b, and somebody gonna ask you that, okay fine, what is the resultant vector if they have some kind of angle? So resultant vector will be this side, and we have to use this parallelogram law. So the parallelogram law say that this magnitude, actually the magnitude of a and b, will be a square plus b square plus 2a dot b. So how you gonna dot these two products? That is your magnitude. Similarly, if you got a two vector, like here is your a vector and here is your b vector. So here is your tail, here is the head, and again tail, again head. So the resultant vector, so it is your resultant vector, c is your resultant vector. It follows that the vector starts from here, goes here. So this can be sum of this way. So I can write it that how they are actually progressing the continuity equation, like c is equal to a plus b. Similarly, if I got one vector a here, another vector b here. So if somebody asked that what is the drill here, like let's say this is your maybe c vector. So what I can write here that, okay fine, never mind, what I can do, just let's say this is your resultant, because somebody has to go, one vector is this way, one vector is this way, somebody has to go maybe a to let's say this guy is going from this to this one. Okay, this is your tail. So they have started from here to here, it has gone that side. Okay, so what we can do here is very simple. Like first of all, there is a c vector here, so I am making this one. So let's say this is a. So therefore, where is the continuity? So if I am going this way, let's say it is p. So OP and PA goes this way, will be equal to this side. Are you getting me? So if I am writing here OP plus P into A, because here is the point A, is actually equal to OA. One equation. Now if I am writing this way, this goes. So first this go and then this go. This will equal to OP. So the second goes like this, OB plus BP, okay, because this whole vector is goes like this. Therefore, I have to choose the following continuity is equal to similarly OP. This one is OP. Now, what you can do is plug this OP here. Or so what we can write here like PA, and we know what is your OP. OP is OB plus BP is equal to OA. Now see here what is OB, OB and OA, OB and OA, this one. So if I am writing here like PA and BP, so what is your PA? PA is this one and BP is this one. So it will actually give you a complete vector. This complete vector is, we can say, let's say R. So this complete vector is your R. So PA and BP is giving you R, and this way is equal to OB minus OB, OA minus OB. So R is nothing but OA vector minus OB vector. So this vector minus this vector, and you can follow the continuity also from here. Like we can write OB plus R vector, because it is going this way to this way, is equal to OA vector. So if you have the situation like nobody is asking you what is your R vector, but they are actually asking you that what is your OC in terms of OC, like OP. Okay, there is a C vector. I have just break it in OP part. So you can always write OP in terms of maybe OA minus PA, or OP is equal to OB plus BP. So this is too much important. So this is the way we actually do vector algebra without introducing anything. It is amazingly simple, and we don't have used any coordinate system to define anything. Similarly, if you got your, maybe this is your, so I am not going to define any coordinate system right now, so I cannot say anything later on. So whatever the thing will come in vectors, we will first define what is the coordinate system and why they have specified that. Mathematicians don't do this one because these operations can be defined on any coordinate system. But as the coordinate system will change, the vector, which is actually a vector, if the quantity is a vector, they will always follow these kind of scenarios. And if I am going to specify some kind of coordinate system, then how these things will actually follow the coordinate system. So in my later video, in the next video of vectors, we will actually understand a very beautiful thing about, let me just state you one more thing. Let me just very importantly straightforwardly say you. So these are things we have actually done. So the fact that we have discussed vectors without introducing a particular coordinate system shows why vectors are useful. So vectors are useful because we don't need any coordinate system to define it. Vector operations are defined independently of any particular coordinate system that I have told you specified. However, eventually we have to translate our results from abstract to concrete. So whatever we have done, it was complete abstract. No need, we just did multiplication without worrying about any kind of coordinate system. Now you are seeing the picture that why coordinate systems are necessary. And at this point, we have to choose a coordinate system in which to work. The combination of algebra and geometry called analytic geometry and is a powerful tool that we shall use in many calculations. Analytic geometry has a consistent procedure for describing geometrical objects by set of numbers, greatly easing the task of performing qualitative or quantitative calculations. With its aid, with this help, students still in school can routinely solve problems that would have taxed the ancient Greek geometer Euclid. Analytic geometry was developed as a complete subject in the first half of the 17th century. Means that in 1600 people actually used to do Euclidean mathematics by French mathematician René Descartes and independently by his contemporary Pierre Fermat. So later on in the video you have understood that why vectors are important because the independent nature of its operation, and now we will understand that how these operations actually translate if I am defining any set of particular coordinate system. So before जब तुम 11-12 में थे तो तुम्हें कोई फर्क नहीं पड़ता, तुम बस वेक्टर्स को डिफाइन कर रहे थे और तुम्हें बस बोलते जा रहा था कि देखो अगर कोऑर्डिनेट सिस्टम ऐसा होगा तो ऐसा होगा, वैसा होगा तो वैसा होगा. बट वेक्टर की एक बहुत बड़ी हिस्ट्री है, जैसे कि मैंने तुम्हें बताया. अगर तुम ग्रुप थ्योरी में जाओगे या फिर तुम जनरल रिलेटिविटी को जब सीखोगे, व्हेन यू विल लर्न अबाउट जनरल रिलेटिविटी, ग्रुप थ्योरी or many other different compact things like string theory, maybe some topological space, where again these vectors, because vectors are not bound to any coordinate system, they can be independently defined, and vectors are set of some numbers. Okay, and these definitions actually arise in it actually concretely constructed in terms of coordinates. So either you are in general relativity, either you are in any kind of space, maybe string theory, maybe high energy physics, maybe group theory. Okay, no matter where you want to do, you have to first to do any operation, you have to first define what is vector. और जब हम क्वांटम मैकेनिक्स करते हैं, पहली बात ये इस बात सुनो, जब हम क्वांटम मैकेनिक्स करते हैं तो हम पहली बार वहाँ पे डिफाइन करते हैं क्या, वेक्टर्स को. और वहाँ पे जो वेक्टर्स होते हैं उनका जो मैग्नीट्यूड होता है, बेसिकली वो जो मैग्नीट्यूड होते हैं वो कॉम्प्लेक्स वेक्टर्स होते हैं. ठीक है, और पूरे क्वांटम मैकेनिक्स है वो क्या है, एक कॉम्प्लेक्स वेक्टर स्पेस होता है जिसे हम कहते हैं हिल्बर्ट स्पेस. और वहाँ भी वेक्टर्स के सारे रूल्स फॉलो होते हैं, और वहाँ भी हमें करना पड़ता है स्केलर प्रोडक्ट, और वहाँ भी हमें करना पड़ता है वेक्टर प्रोडक्ट. बट स्केलर प्रोडक्ट हैज़ मच मोर इम्पोर्टेंस. तो अगर तुम इन सब चीज़ों को अंडरस्टैंड नहीं करोगे कि व्हाट इज एक्चुअली द डेफिनेशन ऑफ वेक्टर, व्हाट इज द वेक्टर, इट इज़ नॉट जस्ट लाइक डूइंग सम ऑपरेशंस. वेक्टर्स आर एसोसिएटेड विद the transformation of coordinate system, then everything will crystal clear to you that wow, that is why we are actually studying vectors. So I am concluding my video for now, and in my next video we will discuss more about it. So thank you very much, and please subscribe my channel if you like it.